Hello everyone, my name is Abhishikth Varma Indukuri and I am from Gokaraju Rangaraj Institute of Engineering and Technology. My group mates are LAKSHMI, HANISHA and GREESHMA. Mohammad Javed Mahdi is our project mentor. My project title is Lung Cancer Detection in CT Scans Employing Image Processing Techniques and Classification by Decision Tree and K Nearest Neighbor. Let's start with introduction. Lung cancer is one of the primary reasons of cancer-related fatalities globally. Lung cancer has two different subgroups. These groups include both non-small cell lung cancer and small cell lung cancer. Patients experiencing lung cancer often experience symptoms like bloody coughing, shortness of breath, weakness, chest pain, losing weight. Let's see CT scans. Lung cancer can be found in a number of ways including radiography and computed tomography. Low-dose CT is only screening procedure that is advised for lung cancer. Although CT is recommended, visual interpretation of these images has the potential to be inaccurate and can delay the discovery of tumor. In order to detect lung cancer in the initial phases, image processing approaches are commonly used within the medical industry. Let's talk about the related work till now. Murphy was proposed lung cancer detection using image processing median filter to eliminate impulse noise, mathematical morphological operations for segmentation of the lung region of interest, from which hierarchic features are extracted and used for classification of cancer by artificial neural networks. The methodology adopted in this project resulted in an accuracy of 92%. Nidhi S. Natarkani proposed median filter picture pre-processing that keeps the edges and reduces noise to increase the quality of the image. Image segmentation to acquire the desired region using the mathematical morphology. SVM classifier groups the lung CT images by locating hyperplane. Selin proposed segmentation approach for lung tumors. Filtered image is then given a threshold treatment. Due to the thresholding procedure, a threshold is set at a particular value that converts a grayscale image into a binary image. It was discovered that the design system could separate tumor of various cancer and non-cancer of the employed data set with a high level of 97.1% accuracy. Let's talk about proposed methodology. It consists of a block diagram as shown. So first block consists of normal input and cancer image in which we take the images, and the next step goes to pre-processing the image, and furthermore we get segmentation process and extract the features. At last we get the type of lung. I declare that it is whether it is normal or cancer image. Proposed methodology. The image database contains computed tomography images of patients with and without lung cancer. The first point in that is image pre-processing. In the field of image pre-processing refers to a collection of methods used to enhance the quality and the appropriateness of images for additional analysis. CT scan images are prone to salt and pepper noise, hence median filter is found to be quite effective technique in eliminating this impulsive noise without blurring the image. It gives best result for image smoothing. The next step is image segmentation. The process of separating out the required region of interest from the image is segmentation. Morphological operations are often used in combination with other image processing techniques, such as thresholding to segment an image or extract specific features. The opening and closing is given in following equation, and in this equation S is structuring element. The next the next step is feature extraction, the most crucial stage in turning input data into necessary attributes is feature extraction. In this stage, the segmented sector of interest key features are extracted. In our study, features such as areas, compactness, yellow circularity, and perimeter are taken to classify the type of lung, whether it is normal or cancer, and its subtype, whether it is malignant or benign. Areas, compactness, euler circularity, and perimeter are all shape-based features that can be calculated from the contour or boundary of an object in an image. The next step is classification. The classification stage involves labeling the CT scan images as normal and abnormal. In our method, KNN and decision tree algorithm used for detection of lung cancer in CT scan. Let's talk about decision tree. The root node, decision node, and terminal node are three different kinds of nodes that make up a DT. And the flowchart is shown for decision tree, which includes root node, decision node, and terminal node. Coming to K nearest neighbor, which is also called KNN. K nearest neighbor is a machine learning algorithm that can be used for classification and regression tasks. The principle of this classifier is feature similarities. The parameter K in KNN represents the amount of closest neighbors that are comprised in the supermajority procedure. Let's talk about results and discussion. Using MATLAB program language, the desired system was implemented. The Kaggle dataset for lung cancer used in the study. The first figure shows the grayscale image of the lung. The second figure shows the filtered image of the lung. The third figure shows the binary image, and the fourth shows the segmented cancer and normal part. By studying the above pictures, we can say that in next step, feature based on shapes such as areas, compactness, euler, circularity, and perimeter are considered. Values of features. So we get a table here. It consists of area, compactness, euler, circularity, perimeter, and the table is shown below. The feature values for the normal, malignant, and benign types of lung cancer are displayed in above table. These values are trained to classifiers. So the next slide is about graphical representation of features and classification. Extracted features and classification is shown as area, compactness, euler, circularity, and perimeter, and the accuracy results of KNN and DT are shown as accuracy. Conclusion. Although the most prevalent and server type is lung cancer, starting stage identification can prevent serious stages and lower its global prevalence. The most active area of research in this field is lung cancer detection in CT scan picture, which is constantly developing and might use many improvements to become more effective. With the use of decision tree KNN classifiers, accuracy was determined and differentiated lung cancer into malignant subtype depending on whether it is diseased or normal. Thank you.